Welcome to another video in this Edge AI Masterclass. In this video, we will look into one of the fundamental building blocks of device communication in edge computing, the UART serial protocol. We will start by looking at the protocol and some of the related terminology, and then go into its working and the wiring. So let's dive in. UART, or Universal Asynchronous Receiver Transmitter, is an asynchronous serial communication protocol. This means that unlike parallel communication, which sends multiple bits at once, UART sends data sequentially, one bit at a time. Also, since the communication is asynchronous, there is no clock to synchronize the data sent and received, and it uses special bits to let the receiver know that data is being sent. We will look into this soon, but let's go over a few terms first. Data is sent from the sender device to the receiver device in packets. Each packet contains the data bits, the synchronization bits, and the parity bit. Data bits are typically 5 to 9 bits and represent the actual data. Then there are synchronization bits, which include 1 start bit and 1 to 2 stop bits, and these are on either side of the data bits to frame the data packet. The third and final type of bit is the parity bit, which is an optional bit for error checking and added after data bits. Another term to understand is the baud rate. This is the rate at which information is transmitted, and it is usually measured in bits per second, or BPS. The baud rate values usually range from anywhere between 9,600 to 115,200. The flexibility in the values of these parameters, whether it be the data bit size or the baud rate, makes this protocol highly flexible and configurable, with the only caveat being that the two devices should agree upon and use the same parameter values. Some of the use cases for this protocol are the GPS module, the Bluetooth module, the serial liquid crystal displays or LCDs that you use to display information, and the communication between your embedded device and your computer when you attach it to transfer your code. All these communications use the UART protocol. With this understanding under our belt, now let's look at how UART actually sends data. Broadly speaking, the process can be divided into 4 steps. In the first step, the transmission starts by changing the data line from 1 to 0. Or in other words, it starts when a start bit with a value of 0 is sent on the line. Once the start bit has been sent to let the receiver know that a data transmission is underway, in the second step, the actual data is sent in either the least significant bit or LSB mode, which is the default setting, or the most significant bit mode, or the MSB mode. For example, let's say that you wanted to send capital P over the line. Capital P's ASCII value is 80 in decimal, and the binary value is 0101 followed by 4 zeros. Now, just like the decimal system, where the least significant digit is the rightmost one as it represents 10 to the power 0, similarly for binary, it is also the rightmost as it represents 2 to the power 0. And so, with the LSB mode, the rightmost bit is sent first, then the second value on the right, and so on. And so the data sent is 4 zeros followed by 1010. If it was MSB, the data would be sent from left to right. Once the data has been sent, next comes the parity bit, which is an optional bit added for error checking. It also has 2 modes, the even mode and the odd mode. The parity bit is calculated by adding the data bits. In our example, for the binary value of P, there are 2 ones, and so the sum is 2. In even mode, if the sum of the values is even, the parity bit is set to 0. If the sum was odd, the bit would be set as 1. In the odd mode, the values are reversed. Finally, in step 4, after the data and/or the parity bit has been sent, a stop bit with value 1 is sent to signal the end of packet transmission. And that is how a UART protocol works. Let's now look at the wiring, which is pretty straightforward as well. There are 3 wires including ground. The RX stands for receiver and the TX for transmitter. As can be seen, in the UART setup, the TX pin of one device is connected to the RX pin of the second device, and vice versa. So if device 1 wants to send data, it uses the orange line, and if device 2 wants to send data, it uses the green line. If the second device is, say, an LCD screen, then it will not be sending any data back, and in that case, the second TX-RX connection, the green line, can be skipped. Finally, the ground is connected, which completes the circuit and ensures signals are correctly referenced. And that wraps up our basic overview of UART in edge devices. If you would like to learn more, we will add some links in the resources section. In the next video, we will look at protocol number 2, the SPI protocol. See you there.